So this video, I am going to show you how to dilate around a point that is not the origin. So I have a little piece of graph paper here, which is going to be helpful because I'm going to show you what's happening in addition to writing it out on paper. All right, so I'm going to start off with this rectangle. So I am going to name these points. Let's see. How about -5, -6, and then C can be -5, -8, which means D has to be -9, -8. All right, so first thing I'm going to do is plot my points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So here's A. And then D should be just right down here because it's -8. So 9, 8, 7, 6, 5. So my other two should be right here. So here is A, B, C, and D. All right. So I am going to give the directions to, oops, we got fuzzy. I'm going to dilate by a scale factor of 2 around the points, let's do -12, -12. Oops, -12, -12. Okay, so I want to dilate around the point -12, -12, which, let's see, 9, 10, 11, 12. I'm pretty sure this is my -12, -12. Okay, so I have a rectangle, and I need to dilate it by a scale factor of 2, which means I'm going to make it 2 times bigger. So this side, instead of being 2, should be 4, and this side, instead of being whatever that is, 4, it will be 8. But I'm not doing it from the origin, I'm doing it from this point. So what that means is that this rectangle is going to be twice the size. It's also going to be twice the distance from the starting point. All right, so what we're going to do in order to do that is I'm going to show you on the graph and also speaking algebraically. All right, so if we look at this, point A right here is over 3 and up 6, which means that if I need to double that, it's going to be over 6 and up 12. So point A prime is going to be right there. All right, point D is over 3 and up 4, so it needs to go over 6 and up 1, 2, 3, 4, 8. So here's my D prime. All right, point B is going to be 1, 2, 3, 4, 5, 6, 7. So I'm going to need to go out 14. So 1, 2, 3, 4, 5, 6, 7. And then instead of going up 6, I need to go up 12. So did I do that right? I lost my space. Let's see. 4. 1, 2, 3, 4, 5, 6, 7. Yes, okay. All right, so here's my B prime. And then I can pretty much tell that C prime should be right there. So I have now dilated this shape by a scale factor of 2 around this point. All right, so what that means is just that it's going to be twice as big and twice as far away. So I basically used almost more of like a slope issue, kind of like, you know, just took how far over, how far up, multiplied that by 2. So I did that twice. All right, now algebraically, what I did is I started with the point. So let's just say A prime, or sorry, A. All right. The first thing I did is I figured out how far it was from this point. So I'm finding the difference between these two. So basically what I did was I added 12 and added 12. And the reason is because that's the point I'm dilating from. So it's almost like I figured out how to get this point to be the origin. So I'm moving this point to the origin, and then that gave me the difference, which is why I added 12 and added 12. All right, so now I'm going to perform the dilation, which was a scale factor of 2, which means that this becomes 2x plus 24, and this one would become 2y plus 24 because I'm dilating it by a scale factor of 2. So I have to multiply by 2. All right. Then I need to adjust it back to where it was. So basically what I did is I moved my point, which is negative 12, to the origin, which means I had to go up 12 and right 12. All right, then I performed the dilation, which was a scale factor of 2, and now what I need to do is bring it back down here to the actual dilation center, which was negative 12. So what is going to happen here is now I'm going to take this and bring it back down to the point negative 12. So if I simplify that, then what ends up happening is that I went from the original point of xy to the point 2x plus 12 and 2y plus 12. So let's see if that's what really happened. So if we look at point A, so A was negative 9, negative 6. If I complete this right here, then I have to multiply this by 2, which would be negative 18, plus 12, which would be at negative 6. And then for the y, 2 times this is negative 12, plus 12 would be 0. And sure enough, A prime ended up at negative 6, 0. So what I did here is I subtracted the center. So let me do this in a different color. So this right here is I subtracted the center from the origin, or the original point, xy. Then right here, I performed the dilation. So I dilated by a scale factor of 2, means that I had to multiply my points by 2. Then I had to add the center back. So add the center to my point. And then this is the simplified rule. So simplified rule. All right, so different ways to do it. It's totally up to you, whichever you like better. So what you can do is take your starting point, subtract the center of dilation, which is basically bringing that point up to the origin. Then you dilate your figure, so we made it 2 times bigger, and then we brought it back down by adding the center back to the point, and that gives us a simplified rule. So we could use this and algebraically figure out what our new points would be for the dilation, or if you have a graph, it's probably just as easy to use the graph. But this gives you an idea of how to do it, depending on whether you have a graph or not. All right, let's do the same thing, but this time let's dilate by a scale factor of 1/2. So I am going to dilate the same shape by a scale factor of 1/2. So again, around the same point, negative 12. All right, so to do this algebraically, here's what I'm going to do. So I'm going to take the point xy. I'm going to subtract the center from it. So x minus negative 2 and y minus, 12. X minus negative 12 and y minus negative 12. All right, now I have to dilate it by 1/2. So that means x over 2 plus 6 and y over 2 plus 6. All right, because that's half of this. And now I'm going to add the center back. So when I add this back, I have to add negative 12 to this. So I'm going to end up with x over 2 minus 6 and y over 2 minus 6. And this should be my final points. Okay, so let's take, we'll just take A. All right, so if we start with A, point A, then A prime. All right, so half of this is going to be negative 4.5 minus 6 would be negative 10.5. All right, and then if we fill in negative 6, so negative 6 divided by 2 is negative 3 minus 6 is negative 9. So A prime should be at negative 10.5 and then down right there, I believe. 6, 7, oops, wait, 7, 8, oh wait, I went one too far. Should be that one right there. So there's our A prime. All right, so I made it half of the size. All right, now, if you want to do this by graph, so that's algebraically, by a graph, C is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So half of that would be 1, 2, 3.5 and up 2. So there is your C, and we'll put double prime actually because this is our second one. All right, and then so here's our D double prime, and then our B double prime will be right there. So here is half of that shape. So what happens when you dilate by 1/2 is I ended up with a rectangle that's half the size of the original, and it's 50% closer to my starting point, so it's only half as far. Now, here's the coolest thing ever about this. All right, so give me a second to get what I'm going to use here. Whoops. All right, I'll just use this, I guess. All right, if I take, oh, I shouldn't use yellow. Sorry, hold on. Let's use a different color. We'll use green. If I take my center and draw this out, watch this. It goes through all of the points. So here's my A double prime, here's my A, here's my A prime. All right, I can do the same thing. From the center of dilation, I'm going to go through all of the points of B. So I went through, here's B double prime, the original B, and B prime. I can do the same thing with C, and I can do the same thing with D. So this, if you look, it's kind of a little freaky here, but this shows you the different dilations of this. So if I wanted to scale by a scale factor of 3, or sorry, dilate by a scale factor of 3, then it's going to go over 3 and up 6. So it's going to go over 3 and 1, 2, 3, 4, 5. Oops, did I count wrong? Oh, wait, I kind of went off, I guess. But anyways, so it should be right there. So here's, if we want to do that one. And then B is going to be along this one. And then C would be out over here. And then our D is going to be right there. So here is the scale factor of 3. But it's all going to follow that. And it kind of looks three-dimensional if you can kind of get your mind to look at it that way. So anyhow, so very cool way of checking what you are doing. But again, to do this on the graph is pretty easy. I would just count. Algebraically, you're going to subtract the center, perform the dilation, and then add the center back. So what you're doing there is you're moving this point over here, then you're dilating your figure, and then you're moving it back to where its new location is. All right, good luck.